Can you see my screen? Yeah.
Yeah, can see it, yeah.
Okay, so as Lucy said, we've been working with Growing Sudley now for over 10 years to develop their vision. And although this is by far the longest project to date, much of our work starts with the principles of permaculture, and this building has developed really along the same lines. So even though it's 10 years, it feels like it's not. It's 10 years of like growing ideas and things that we've gestated onto other projects. So in developing their approach to caring for the walled garden, Growing Sudley have followed the permaculture principles, working with nature, thoughtful observation and respecting dependencies to support the whole. The sustainability strategy for the building has been developed in a similar way. I'm going to talk a little bit about the journey we've been on so far, as I think that the process has been as interesting, thought-provoking and challenging as the end result will be. So, to set the scene, the building that we refer to as the changing rooms, as its name suggests, is a dilapidated council building that was last used as changing rooms for the adjacent sports pitches within the grounds of Sudley House. So the plan on the left there, the blue line is the garden, the walled garden that Lucy showed on the video where we do lots of the activities. And then the red line is the changing room building, which is adjacent to it. And then the other large building towards the right of the blue line where the garden is, that's Sudley House, which is a museum run by National Museums Liverpool, for those that don't know. So whilst this building sits in public parkland, it's reached via a private driveway, which is some distance from any adopted roads. So that's the grey road there, which has caused us a few issues in its own right. But our initial structural and historic investigations identified that although the building was in a poor state of repair when we looked at it, it was structurally sound and capable of conversion. It's got solid masonry walls throughout the building that support a concrete slab roof and an existing 60 amps electricity supply, mains, drains and water. So through engagement and consultation with the local community over a number of years, it became clear that there was unanimous support to see the building brought back into use. The aim is for the building to be restored in as sustainable a manner as possible, supporting the values and priorities of Growing Sudley, using renewable technologies, aiming for a low carbon community asset. The sustainability of Growing Sudley as a thriving community business will be aided by the income generated from the conversion of this building into a therapy and wellbeing centre, with the income generated being used to support the ongoing work and maintenance in the walled garden. So it's about the sustainability, not only from an environmental perspective, but from an economic and social perspective as well. And we decided on therapy rooms that following quite a bit of market research and also support from John Garrett at Ulla Road Eco Offices, who had first-hand experience of developing their own zero carbon building there. And also, you know, he knew that they had a lot of demand for therapy rooms, and it married quite well. Well, it married exactly with what Growing Sudley was all about. So the existing cellular layout with the solid walls made it a really good candidate for therapy rooms because it meant that it required minimal structural alteration, and the solid internal walls also provide good acoustic separation for privacy. That drawing there is what we've called the design freeze, I suppose. So we've got 8 therapy rooms, a community room and associated sort of storage and toilet facilities. It's quite a simple building, but actually there's very little alterations to the existing structure. All the walls that you can see in there are existing. I think we sort of took some rearranged the toilet cubicles at the top around this community room area, but that's about it, which obviously keeps costs down considerably. We knew that the capital works would be reliant on grant funding, and so the design needed to be as lean as possible. So the initial cost plan that was prepared to support the grant applications indicated that it would cost around £1,000 a square metre plus VAT. And while we knew at the time that would be tight to do, we thought it would be achievable based on market conditions at the time. And we'd already delivered other low-cost projects in the city for less than that. So I think as a team, we thought it was going to be challenging, but it wasn't impossible. But of course, Brexit and COVID then happened alongside an unnecessary protracted planning process. But as Lucy said, that's an ongoing story that's too long for tonight. We basically, as part of the first design development of the project, we got lots of contributions from organisations as well as the community. So some of those people might be on here, I think, people like Andrea from B for Biodiversity, Peter Brash, an ecologist, as well as national organisations like Architects Climate Action Network. We took on board their suggestions to help develop a low carbon assessment of the building and identify opportunities. In a way, I guess this is much like a site analysis we would undertake for all of our design projects, and it has become very much part of the way that we do and the way that we develop designs. I think it became clear to us all that there were two areas of reshits that we needed to pursue that would align with Growing Sudley's briefer names. Unfortunately, in our office, we had recently got a qualified passive house designer, so she was really keen to help steer this. So this sketch really just shows some of the things that just our observations, that some of them were things that people came up with. So we did a workshop with children. Somebody had an idea for biodiversity on the roof and the green roof, and bug house, hot tub on the roof came up, which we weren't able to accommodate. That was my child, but he can still live in hope. So basically, the two areas that we knew that we needed to pursue were natural materials with low embodied carbon, and then also renewable technologies. And that would bring us towards a low carbon or zero carbon building. During lockdown, there was been a big push from architects' practices and others in the construction design industry who recognise our responsibility to help push towards climate change goals. And so we undertook a great deal of detailed research and spoke to many people, and we continue to sort of evolve and share this knowledge. And it's like an ongoing weekly CPD in our office that's really sort of taken a life on since we started with the project. And on this slide, the RIBA, which is the Royal Institute of British Architects, they produced a sustainable outcomes guide, as well as the LETI Climate Emergency Design Guide, which you may be familiar with. They're both leading industry documents that highlight the standards for future building. Targets are measured against building CO2 output and energy in use, and they provide guidance for target U values. If I'm getting too technical, then if anyone's got any questions, I can try to answer them at the end, but I'm sort of assuming that a few people you've already got some knowledge about this. So as part of our design process, we aim to achieve more than just the baseline regulatory minimum for U values and energy use, as these represent unsustainable practice beyond 2030 and will not reach the government target for a net zero carbon economy by 2050 if we don't. So that was our starting baseline for what we were hoping for when we first started the project. And obviously our assessments consider the whole life carbon value of the building. So it's not only about its performance in use, but also how much embodied carbon is associated with the building's construction, including the energy used to extract the materials, transport them, and so on. We found when we were looking into the natural material side of things that there was an emerging number of exciting materials on the market, but each one of them came with their limitations for this particular building. So, for example, mycelium was of real interest to us just because of the character of it, but it's got an excellent insulative and fire retardant properties. But when we looked into it in more detail, we could only really use it if we were installing it internally, because it's not UV stable. So if we'd have wanted to use it as an external insulation to clad the building, we would have then had to overclad with something else, which would have presented a cost issue. So when we looked at insulating the internal face of the building, the difficulty with that is that it would take space off the rooms on what was already quite a tight plan. So we were presented with a number of these different challenges with the products, which basically ended up meaning that it helped make our decision process easier, I guess. And so what we realised is that we were looking for an external insulation material that could actually be robust and stable and be there as a finish in its own right. So the product that we went for in the end was hempcrete. So we've been doing quite a lot of research about that, and we're hoping that when we come to apply it, we can run that practice as a workshop so that we can share the knowledge about how to do it with other people, because it's not been done in Liverpool before. So that's quite exciting. Interestingly, perhaps the most disappointing discovery was that we found the higher the embodied carbon in making the material, the cheaper the price. Essentially, oil-based insulation products like PIR, so the type of product that you see on projects like the external envelope on Grenfell, are substantially cheaper than natural products like cork, which is actually, you know, carbon negative due to the amount of CO2 it absorbs in its production. So that was a big, I guess, eye-opener, I guess, for all of us. And then alongside the material review and the passive house approach, we were also working with the services engineer to decide on the most sustainable heating and ventilation system for the building. So despite natural gas being the far cheapest option in the current market, this is fundamentally against the principles of the project, especially given there was no mains gas to the site. So that was definitely discounted from the beginning. And then we considered a number of options through like an iterative design process. Over several workshops, we were discussing the merits and pitfalls of a variety of materials and products, and then the targets for performance and the subsequent effect on the feel of the spaces and the level of control by the users of the building. And I think what we discovered really was that the existing building's form factor, so its shape, and then its thermal mass, as well as the proportion of glazing, because there's not much glazing in the building, it's basically limited the provision for ventilation, so it doesn't really lend itself to a thermally efficient design, and then it performs poorly with regard to regulating its own temperature. So when we originally looked at it and we were using LETI target U values, what this service engineer discovered was that it would cause an undue overheating effect to the building. Once the external temperature exceeded 10 degrees, it would be basically too hot inside. So we had the problem of overheating because of the building users basically in the spaces. So what we discovered was, like, so I think the initial thing was like insulate the building and then it wouldn't need any heating, but what we discovered was that wasn't going to be a comfortable space to be in. So the strategy was then to reduce it to 25% improvement on building regs compliance. And what we looked at all different kinds of options, and I think some of the considerations that we needed to make when we were looking at things like an anaerobic digester, which was really exciting, was the amount of maintenance that would have been required for that. Lucy would have probably had to have like a full-time member of staff to make it work. So we thought we'd probably save that one for another day. Another project wasn't in its own right. But what we decided was that the most appropriate system was air source heat pumps, and the reason was because it could also provide the ventilation for the building too, because of this cooling effect that we needed. So in discussing appropriate heating and ventilation systems for the building, we took into consideration robustness, the use of the spaces, and the ease of installation. Quite limited floor to ceiling heights in some spaces. So we supplemented the air source with a MVHR system, making use of the existing ventilation holes that already existed around the building. So as you can see, this was not without testing a number of other possibilities. I guess this is my final slide really, and this is just about the compromises and conclusions. So the existing floor to ceiling height within the building was really restricted. So maintaining a suitable tolerance whilst meeting building regs compliance was only achievable with the higher performance synthetic products in these areas. So we decided that, you know, we had to compromise in that regard because it's better to insulate the building than not at all. But natural materials just require more space to match the thermal performance of the synthetic counterparts. So we recommended those where space allowed, which is why the entire envelope of the building we decided to do in hempcrete. And also, I think that was also a conscious decision that so that we could show people that that was a product that you can use. We considered that new openings for openable windows were not possible due to privacy, and that individual controls within the spaces were preferable due to the mix of uses. So that's the other reason why we went for air source. Overshadowing from trees and the vulnerability of solar panels to vandalism could make it impractical, but we thought that they would be suitable to add at a later date, which is why we did the crowdfunder, because air source has a higher electricity demand. So in the future, or as soon as we can, installing the solar panels will hopefully counteract that. We will probably do a full whole life carbon assessment to determine the final amount, kilograms of CO2 equivalent and the global warming potential of the building. And then we're also planning on installing a biodiverse roof, which hopefully will offset all of the carbon use in the building, and mean that we've got a carbon negative or a zero carbon building. And I guess this just summarises really the main strategies for the design and where we're up to. So phase 1, we'll have a fully serviced building. Phase 2, we'll do our hempcrete installation, and phase 3 will be our biodiverse roof and add on our solar. So I guess in summary, to use low carbon natural materials has a cost uplift currently. So I think our conclusion was that like a hybrid approach, due to the limitations of the existing building and the desire to provide an environment that was fit for purpose at a low budget, is probably a compromise that we're happy with. Would you agree, Lucy?
I would go further and say we didn't really have any choice.
Yeah.
So we had to be happy with it. I mean, I think it is worth pointing out, without going into any of our pain, that prices have literally doubled, you know, since we put this budget together and got the funding in August 2019. The cumulative effects of COVID and Brexit and shortages and, you know, suppliers issues and all the rest of it, costs literally have doubled. So I think we would have probably had to make compromises on our budget anyway, wouldn't we, Sue? And
yeah, I think unfortunately at the moment there's lots of new materials coming on the market, but we're just a little bit early for them to be used readily enough for the prices to be competitive on a project like this. So I think it's important to try and showcase them where we can, not just because you want to showcase them, but because it makes sense to use them. Yeah. Because then the more that the people know about it and the more we learn about it and we share that knowledge, then the more of the people will feel confident in using it, and obviously then the prices will come down. Yeah. And what we're finding is that there's a big link between natural building materials and heritage projects, because you know, heritage renovation involves natural materials and lime-based products quite a lot anyway, so there's a happy marriage between those two things. So I think they're coming together more than before. It was seen as like all these separate things and people weren't working together, but there's been a lot of progress on that over the last year or so, well, during lockdown, I would say.
Can I just pause this and say thank you very much, Sue, and